Section 4.5 is linear inequalities. Our goal is to graph the solutions to a linear inequality in two variables as a half-plane and graph the solutions to a system of linear inequalities in two variables as the intersection of the corresponding half-planes. On page 263, we have a linear inequality in two variables, such as y is greater than x minus 3, can be formed by replacing the equal sign in a linear equation with an inequality symbol. A solution of an inequality in two variables is an ordered pair that makes the inequality true. A linear inequality in two variables has an infinite number of solutions. These solutions can be represented in the coordinate plane as the set of all points on one side of a boundary line. Example 1 says, is the ordered pair a solution of y is greater than x minus 3? We will let x be blue and y be pink. We're going to plug in 1, 2 for part A and -3, -7 for part B. For part A, our y value is 2 and our x value is 1, so we have 2 is greater than 1 minus 3. Notice I have a question mark over the greater than sign because we aren't sure if this is true yet. 1 minus 3 is -2, so we have 2 is greater than -2. This is true. So we would say yes, 1, 2 is a solution of y is greater than x minus 3. For part B, we have -7 as our y value and -3 as our x value. -3 minus 3 gives us -6, and -7 is not greater than -6. So we would say no, -3, -7 is not a solution of y is greater than x minus 3. Again, remember this first inequality has a question mark above it because we aren't sure yet if it's true, and in this case, it ended up not being true. The work for this problem is written out on the next two slides. And now I would like you to try homework number 1 on page 263. Determine whether the ordered pair is a solution of the linear inequality. We have y is less than or equal to -2x plus 1 with the coordinate point 2, 2. Something I would like to point out about this example is we have less than or equal to. So in the previous problem, if we had got two numbers that were equal to each other on either side of the just greater than, that would have been a false statement. However, if you have less than or equal to, we can end up with the same number on both sides.